Hi, this is Lee from the Robby team. It's been quite a while since our last video. We've been doing some physical work on the robot, and the realities of working for money sometimes interfere with quality time with our hobbies. Anyway, in our last video, I said that in this video we'd be looking at using the Robby Framework to connect computers together in a peer-to-peer network, providing the ability to control the robot remotely, as well as allow for having multiple robots or other devices able to communicate freely with each other using TCP/IP over Wi-Fi or Ethernet. So that's what we're going to do today. As part of this, I've finally officially mounted the tablet that will run the MCP on the robot Antwerp. You can see I have the little WPF program on it, running on it, that I use to demo functionality, giving me touchscreen control over the robot's tracks. So I can hit forward, and the tracks go forward, and I can hit stop, and the tracks stop. You can also see I have a similar program I've written loaded on the laptop I'm running Camtasia on for this video. It also provides touchscreen control for the tracks from the remote laptop. So there's forward, and there's stop. Also, I can say, "Hey Antwerp, say hello."
Hello, my name is Antwerp. My goal in life is to fetch a beer from the fridge.
Or Antwerp, move forward.
Moving forward.
Antwerp, stop.
Stopping.
Now we've seen using voice commands before, but here we've done something a little different. Now we have the remote laptop computer receiving and processing the spoken commands, then passing the resulting command string to the tablet on the robot, which executes the command and provides a text-to-speech reply. So now that we've looked at how it works, let's have a quick look at what I did in the Robby Framework to make it possible. We'll open up the Framework's design UI and look at the networks I'm running on the tablet and the laptop. First, we'll take a look at the network running on the remote laptop named Antwerp Remote Peer Net. You can see it has two channels, the Antwerp speech channel we've seen and talked about before, as well as the remote peer channel. As I said, we went through the setup for the speech channel and its speech connector in our last video, but I do want to point out one thing that's a little different this time. So I'm going to open up the channel builder and open up the speech channel. We're going to open up the configuration for the speech connector, and there's just one thing I want you to notice on it. I want you to notice the Use TTS Response checkbox here. Notice that it's unchecked now, and this is what makes it so that we don't get the spoken replies on this computer for the commands. And now let's take a look at the Antwerp Remote Peer Channel. You can see this is very simple. We've seen all this before. It's simply a TCP connector. But this time we've configured it to talk to the IP address on the tablet. So very simple TCP/IP connection between the two. Now let's take a quick look at the network running on the tablet. That's the Antwerp Bot MCP network. Here you can see we have 4 channels. We've got the range sensor channel, the body movement channel, and the Antwerp Bot Peer channel, as well as the voice channel. Now we've seen the range sensor channel and the body movement channel before, but let's go in and take a quick look at the other 2. Actually, we're not going to spend much time on this one. This is about exactly like the Antwerp Remote Peer channel, except that here we have the TCP connector configured to go the other direction from this computer over to the laptop, or from the tablet to the laptop. Now let's have a look at the voice channel. Here you can see we have a new connector that we haven't talked about before. This is called the voice connector. The voice connector just does text to speech, as opposed to the speech connector where it does speech recognition in addition to text to speech. So looking at the configuration for it here, you can see there's just 4 properties. In addition to the instance name you always have in all connectors, you have the voice, which is the name of the Windows 10 narrator voice that will be used for the speech. You can see I have it set up as Microsoft Hazel Desktop for Antwerp's voice. I just find the British female voice more interesting than the stock male American voice that's usually the default on Windows 10 systems. The other 2 config properties for the voice connector are phrase schema prop name and start phrase. Start phrase is intended if you want to always have the same preface on all phrases spoken. We're not going to use that here for Antwerp. The phrase schema property name is more important. To trigger speech in the connector, it is necessary to send a message from the MCP to the connector, which of course must be schema compliant for the channel. The phrase schema prop name property is used to provide the connector with the message schema property where the phrase to be spoken can be found. You can see I tried to keep it straightforward here and used a property named phrase. Go figure. So in this video, we've seen how you can use the Robby Framework to set up true peer-to-peer communication between computers and other remote devices. In a future video, we'll look at a very different network setup that comes out of the box with the framework, where the remote computer can be set up to completely bypass the local MCP on the robot, providing direct remote control of the devices connected to it. This is accomplished by using a TCP connector on the MCP side of the channel. Well, that's it for this video. In the next couple of videos, we're planning to start putting together the pieces we've been building and work towards our first actual behavior for Antwerp. Most likely this will be something akin to a simple safe roaming behavior like you'd see in a Roomba. So there it is for now. Thanks for watching.